Good morning, students. Today's lesson is the lesson 6, unit 13. What is the atomic theory? Go to the page 629. Take your book and a pencil to answer some questions. Okay, let's start here with the adjectives of the class. Explain that matter is made of atom and describe the structure of an atom. Identify some element and describe how the elements differ from one another. Compare an element to a compound. Fill this part, the lesson vocabulary. The lesson vocabulary, you have to look at all parts in the book. And all the vocabulary that you see are here described below. Okay, atom, element, molecule, atomic theory, and compound. What is an atom? What is an atom? Atom is the smallest unit of the element that maintains the property of the elements. Like the gold is made of the one type of atom. If we take the gold and divide in many pieces, the flakes gold, it's still gold. And we continue cutting in many pieces. We're going to the smallest part of this matter, and we call atoms gold atoms. If you see here, all this part, the one cell that is described here in this picture is an atom. That's an atom. In this case, an atom of gold atoms. Look at this picture. Let's read together. More than 2,000 years ago, and instead of all matter is made of tiny solid ball called atoms. The word atom means invisible. Something important that you need to know about the atoms are that the atom is the smallest unit of matter that cannot be divided and still be the same element. If you see an example, I divided the block of gold and a flake gold, and we continue dividing pieces like the solid smaller that continue being the same element. It still be the same element, atom. In this case, it's still the gold. It was 400 before Christ. Democritus was a philosopher, scientist. He called atoms that substance can be broken down into increasingly smaller units. But if you see here, that all still at the end remains and maintains its property of this element that we call an atom. Are the building block of matter. All the things around you are atoms. It's made of atoms. It's like the blocks when you do your leg or something. The basic unit, the single unit, that's an atom. Okay, continue with a teeny tiny theory. Here. The atomic theory is a scientific explanation on the structure of the atoms and how they interact with each other. The scientific theory, they describe the atoms as made of proton, neutron, and electrons, and they interact with another atoms. Okay, the atoms are building block of matter. We describe that. The current atomic theory is that an atom is smallly empty space, and its center, it's really small, dense core called the nucleus. This here is the nucleus, and the nucleus is surrounded by the electrons. The current atomic theory states an atom is mostly empty space, mostly. At the center of the atom is a small, the dense core called the nucleus, which is surrounded by electrons. That's a picture how it looks like. That's a model how you understand how it looks like the atoms. It's not exactly like that, but it's just a model to explain how describe the structure of the atoms. The nucleus here is in the center. The protons are in for the proton and neutrons for the nucleus is the core. Okay, and the electrons surround the nucleus. And the proton is a positive charged particle found in the nucleus in an atom. The neutrons are particles found in the nucleus, but the neutrons has no charge. That's the difference with the proton. Proton has a positive charge. The neutron there has no charge, and a difference. The electrons are negatively charged particles that speed through the area around the nucleus that we call electron cloud that moves surround all the nucleus, and that's electrons. Okay, that's how to be the electrons surround the nucleus. This is an example of lithium atoms. The electrons move around the nucleus, surround the nucleus, and the protons is in the nucleus. Neutron is in the nucleus too. But if you see the lithium is the third in the periodic table, the third element in the periodic table. That means that we have in order the elements according to the atomic mass. Hydrogen is the first, has one proton in the nucleus. Helium is the second, has two protons in the nucleus. And the third is lithium because has three protons in the nucleus. And let's go on. All the range of the elements in the periodic table, it's according to the protons in the nucleus, the number of the protons, because they give it the mass. And it's atomic mass. Okay, now that we need to draw and label the carbon atoms. If you see here we have it here the information. The carbon atom has 6 protons, is the 6th element from the periodic table. Has 6 neutrons and 6 electrons. We need to put in the correct order. Remember, the proton and the neutrons are in the center, and the nucleus, the core of the atoms, and the electrons are surround the atoms, surround the nucleus. That's an example. We have to draw in the correct place where we can find the electrons, protons, and neutrons. Okay. Continue here. That's part of your homework. You have to do exactly this problem. The protons has 6. In this case, the protons, the nitrogen has 7. Here was the carbon 6. And the next element in the periodic table is the nitrogen, and nitrogen has 7 protons. You have to draw it by yourself. We continue here and compare what would be different between proton, electron, and what is it. We compare them between proton and electrons. Okay, remember the proton is a positive charge. We found in the nucleus. Electron has negative charge and is around the nucleus. And what is the difference of both here? In this case, all made. They are the building block of matter. Okay, that like this. Okay, positive charge in the nucleus. The mass, it's 2. The mass of the proton is approximately, that's more than I told you. 1 positive charge in the nucleus. Mass of the proton is approximately 1,840 times as the mass of the electrons. And here the electrons is negative charge. Electrons are present outside the nucleus and of the atom. They are spread around the nucleus, and the mass of the electrons is considered to neglect. The mass of an electron is considered too negligible. And both has in common something, particles that are made of atoms. couple of together. We are now on page 634. On 634, we have here the molecule. The molecule is made of two or more elements joined together chemically. That's a two or more element. Could be the same element or different elements. That is a molecule. For example, there's a molecule of water that's joined by hydrogens and oxygen. They're held together, but are different elements and are different than oxygen. Oxygen are two elements. They're the same. Two oxygen and nitrogen. That's two atoms. It's two atoms joined together and it's a molecule too. Could be different or the same elements. That's a molecule. How the molecule form, I already explained. And a molecule is made up of two or more atoms joined together. How does a molecule form? Many atoms go through this chemical change with a different same type of atoms and form molecules. A molecule is made up of two or more molecules joined together chemically. Okay, there's another person that he organized the period, all the elements on that time. It's a mid 180s. He organized all the elements by the property and increasing mass. The scientist is Dmitry Mendeleev. The scientist still organized the elements by his work. His works. Okay, this Dmitry Mendeleev. That's the name you can see here. Okay. An element is a type of matter made of just one kind of atoms. Elements are substances that cannot be broken into the simpler substances. All atoms are made of elements have the same number of protons. For example, we have the 118 elements that all these elements are in the periodic table. The boron is an element, gold is an element, iron is an element, oxygen is an element, helium is an element, nitrogen is an element, carbon is an element. Why? Because it has one kind of atoms. All that together. Gold, if you remember, when you divide in many pieces, there was only one specific type of kind of atoms. That's the same for another elements in the 100 of the periodic table of the 118. Okay, that's an element. And something about the elements. And electrons are far from the nucleus. We know about that. So the electrons can be gained or lost for another elements. Can be gain or lost. Another thing you need to know about elements, that different atom has the same element and can contain different number of neutrons. The neutrons, if you see here, when an element has different numbers of neutrons and is the same elements, in this case we call isotopes. This is an example for an isotope. The hydrogen isotopes, the first, if you see here, we don't have a number, we don't have any neutrons, and we call protium. And the second hydrogen isotope, we only have one neutron. You can see here, we call here deuterium. And the third, in this case, we have two neutrons, and this isotope we call tritiums. Okay, the protium is the first, the second is deuterium, and the third is tritium. That's only for explain what is an isotope. And the electron we can gain or lose, and the neutrons we can have different numbers of neutrons, and the protons, they remain the same at all the times. you're never gonna see the protons in the nucleus change. Can be changed the electrons, the numbers of the electrons, can be changed the number of the neutrons, but not the protons. That is something important you need to know about it. Okay, that's an example. Include a example of elements include neon, mercury, chlorine, silver, and copper. I think you ever heard that. Okay, those are 118 elements in the periodic table. If you see all the elements are here, there's now in this moment, and all these elements have made of one kind of atoms. Okay, that's some example from the elements. Chlorine is the number 17. You see here. The uses for chlorine is disinfecting, water, making paper, paints, plastic, and dyes. This silver is another element of jewelry. Its most common uses: silverware, photography, welding of solder, mirrors. That's the uses for silver. Copper, according for the number of protons, number 29, that uses plumbing coins, electrical wires, all the wires, because the properties they use for electrical wires, making brass and bronze. Neon, that's another for the neon lines. Okay, the number is this noble gas element. Neon has 10 protons. They use it for neon sign, helium neon lasers, television tubes, and refrigerants. Mercury, the mercury has 80 protons in the nucleus, and you see all the electrons around the nucleus. And they use it for a laboratory instrument like thermostats, thermometers, dental fillings, pesticides, etc. Okay, continue. You need to write here what are the uses of the atom and the element. We need to use the term atom and element to explain what made the silver and gold different. Okay, remember, what is the atoms? All the around atoms is made of atoms. And what is the elements? Remember, an element is one kind of atoms. And remember here, silver and gold, why they're just so different. You need to explain me according to the element and atom why they're so different. Remember, has the silver the same kind of atoms that the gold has? That's a good question. You have to tell me. I answer according to the question. And here they have a now for the compound. In this case, a different than a molecule. Molecule could be elements. Could be saying that a molecule is a substance formed by atoms from more than two elements. A different than a molecule. The molecule could be the same element or not. In this case, are only for system for by atoms to more my elements that here needs to be different. Needs to be different elements. And molecules could be the same and different, and compounds only different, two or more different elements. Okay, let's read here. Part of my atomic theories state that different types of atoms combine and to form chemical compounds. Okay, that would say Dalton. Dalton was to state his atomic theory. Okay, continue. That's a molecule. That's a carbon dioxide. The carbon dioxide has only one carbon and two oxygens. That's the name, carbon dioxide. The property of the compound are often different from the property of the elements that form it. For example, atoms of carbon and oxygen will react, forming a compound carbon dioxide. That's the atomic theory. The oxygen and carbon is joined together by the chemical bonding, and they form a compound. The compound is a carbon dioxide, what we expel when we breathe. Take oxygen and exhale. That's a carbon dioxide. The compound has its own properties. They are different than those the carbon and oxygen. When the molecule when the compound form, the new product is totally different at the beginning. Oxygen and carbon are different than the elements at the beginning. In this case, the compound carbon dioxide is totally different, has different properties. And another example for a compound is we use with a fireworks colors. And when you use a fireworks, we see so many colors and lights. Some of the colors in the fireworks come from the compounds. For example, the calcium chloride, which contains 1 calcium atoms, and for every 2 chloride atoms result in orange colors. The yellow, the sodium nitrate, it produces a yellow color. There's only 1 sodium and 1 nitrogen and 3 oxygen. That's made a compound of sodium nitrate. And lithium carbonate is produce the red colors. It contains 2 lithium, 1 carbon, and 3 oxygens. That's a property totally different than the elements that they form. Okay, let's answer this part. The picture you have at the beginning of the lesson, how does it look like? Okay, the building blocks look like a model on several atoms bonded together to make a compound. If you see the spheres and the structure, it look like a molecule. Oh, this lesson we're going to see all the molecules around us. Funny. That's funny. They call it atomium because the structure look like atoms. Okay, on this part we're going to fill it here. And the fructose is often called the fruit sugar. For every 6 atoms of carbon in the compound, there are 12 hydrogen atoms and 6 oxygen. In total, if we add the 6 carbons, the 12 hydrogens, and the 6 oxygens, and with all this together, they made 24. That is the total of the elements. Okay, let's do math of this. Use fraction. Carbon atoms. Remember how many carbon do we have? We have 6 of the total, 24. It will simplify. It's just 1/4 of his proportion. And now the hydrogen, we have 12 hydrogen of the 24 atoms in a compound, and we simplified it's just 1.5. Now here, 6 again divided by 24 is 1/4. All of this together form the 24 atoms, all the 100% of the compound. That you have to do on this part. And it's exactly that you have to do in this problem in your homework. If you see here, you have the total, you have the carbon and hydrogen. You need to write here, and how many carbons do you have? Carbons as a fraction, and hydrogen as a fraction. You need to write the fraction here. I not give it to you. The same here. You need to write as a fraction. And here the opposite. If you need the total, you have the total. How many carbons do you have? You need to write how many carbon and how many hydrogen. Let me put it here for carbon and here for hydrogen. How many carbon? Don't you see here? And how many hydrogens? You have to write it. The same for the third. The carbon dioxide. How many carbons? How many oxygens? Okay, you have to complete it yourself. I'll only give you some clues. Okay, the same for here. You need to label the parts of those atoms. Remember the positive who has the positive charge, and the letter A, that's all this together. What is the name of the letter A? Who is the letter B? Which particle is the letter D? And what is the name of this particle that moves around the nucleus? As the letter C. Okay, complete this part of your homework. And the sequence, you have to tell me the sequence who is the smaller and the greatest. Remember, you have the answer in your book. You have to check out when you complete this part. And okay, careful here. Remember, you're not going to write exactly in the same word. You need to unscramble. Unscramble means you need to put in the correct order in according to the definition that you have here. The smallest particle of element, let me see, probably is an atom. Okay, I'm sorry here. Atoms. Okay, try to do your best than me. Atoms. Okay, it needs to have the same number of letters and in the right position. Try to do it by yourself. Complete the whole page, and at the end of the circle part, you need to put it. This is the hard word. You need to discover all this answer with all these letters. You need to find the element here. That's the surprise in the present. Bye. See you in another class.